I think so, but I just saw that mine was on there too, and I wasn't sure, so I just wanted to give people the option to. So you don't have mine with you. Okay, so I have the broadcast on. I'm going to try and scoot this closer so that people can hear me better and see it on the board better. No, they didn't. I just barely turned it on. Pretty bad of me not to tell you that. Would you mind holding onto this computer while I scoot the desk forward real quick, just so I can get people closer? Thank you. Yeah, got all the markers. Okay, hi guys. Sorry for the rearranging. I'm trying to get closer to the board so you guys can see better and hear better. So I hope this works. I'll also just try and talk louder. So I sent out a survey today to figure out what you guys wanted to go over. Just as a note, because I normally start reviewing for these office hours at like 7. So anything that doesn't come in by 7, I don't take into account when I'm deciding what to prep for. And so I just saw that there were quite a few that came in like at 7:30, and that just doesn't give me enough time to like prep for anything. So hopefully you'll still be able to go over some of the questions that were submitted after that, but I just wanted to let you guys know that just for future reference. I hope the test went okay. I'm sure a lot of you are pretty worried about it, but it's going to be curved. It was hard for everyone, so I wouldn't worry until there's reason to worry. And so I guess with that, I'll just get started here on the first question. Let me see what it was. Okay, so I'm going to start with problem set 8. And I had a request for problem number 2. So let me open that up. That's where we're going to start, I think. Oh, wait a second. I think I also had. Actually, I also had number 1 requested, so I'll do that one as well. Okay, so the first one on there is about Solomon and his basket company, and how monopoly might work. So it says that Solomon is the only basket maker in his village in Sierra Leone. Each day, 8 people from Solomon's area come to him to buy a basket. Their reservation price and willingness to pay or demand is given by the table that he gives you. So we're supposed to use that information to graph the demand curve. So I'm just going to put up the information that he gives us real quick. It's 16. Okay, so this is the information we're given. We have each customer and how much they're each willing to pay individually. So customer A is willing to pay $16, customer B is $14, etc. So how we would draw the supply and demand, or the demand curve, would be by probably just putting some of these numbers on the y-axis for price, and then just filling in logically. Okay, so we look at this list and say we want to charge $16. We want to know what this intercept is right here. Or sorry, we want to know how many are going to be demanded at this point 16. So we see that there's only one person who's willing to pay $16 or above, and that's person A, right? So down here, we're going to have a quantity of 1 at the price point 16. We go down to $14. There are 2 people that are willing to pay at least $14. Person B is willing to pay 14. Person A is still willing to pay 16, so he would still buy if it were $14. So then we have 2 that demand at 14, and so forth. That's how it will go with the rest of these prices. At $12, there are all 3 of these people are willing to buy. And so we can just fill it in like that. Okay, so that's our demand curve based on the information that we're given. So willingness to pay really helps us determine the demand curve. Okay, so let's say it costs Solomon $3 to make each basket. Let's say Solomon has to charge everyone that comes to him the same price. So he can't price discriminate. He just has a price tag and everyone pays that price rather than maybe trying to price discriminate by charging the people who are willing to pay more money. So he has to charge everyone $3. So what is a socially efficient number of baskets that Solomon should sell? Well, Solomon should sell to everyone that values the basket at least $3, and that would be the socially efficient number of people to sell to. So he's going to sell for $3 right here. This is how much it costs him to make a basket. And anyone above this $3 point would be willing to pay. So the person at $2 isn't willing to pay anymore. So H is going to drop out of the market because he's down here below where Solomon would be at the minimum price that Solomon would ever think about selling, because that's the marginal for each basket. It's going to cost him $3, no matter short term, long term, whatever. But all of these people from $4 and up will be willing to buy a basket. And so the socially efficient price that Solomon would charge would be $4, because that's the as low as you can go without going below $3, according to these preferences of these customers. So the socially efficient number of baskets that he would sell would just be everyone up to G. So 1, 2, 3, 4, 5, 6, 7 baskets. That's the number that he'll sell. And so let's say that Solomon charges $4 per basket. So let's say that he's charging at this point how much money is he going to earn? We can see that he's charging $4 for each basket. It cost him $3 to make each basket. So he's making $1 profit per basket. And he's selling 7 of them, which we just found out in the last part of the problem. So he's going to make 7 times $1, so $7. How much surplus will his customers earn? So his customers are going to earn their willingness to pay minus the price that he's charging. So that's going to be their consumer surplus, right? This guy was willing to pay $16. He only had to pay $4, so he got $12 of consumer surplus. This person was willing to pay $14, only paid $4 again. So their consumer surplus is $10. So you could just subtract 4 for each of these numbers, and so forth. And so these are all the different consumer surpluses that are possible. So if you just add up all of these numbers, then we'll get the total consumer surplus. So 10, 20, 30, 32, or 42. So total consumer surplus would be 42. Feel free to stop me at any point if you want to. Okay. Okay, so now we're asked to complete the total revenue, marginal revenue columns. So I'm going to erase some stuff up here and draw those up. We need this again at any point in the problem. Oh, it is. Okay, so total revenue, if the price is 16, would be 16 because he sells one basket there. If he sold at 14, he would sell both of these baskets because both of those people are willing to pay at least 14. So he would get 14 times 2. So for, sorry, let me start over again. Total revenue is going to be whatever quantity he sells times whatever price he's selling them at. So if we're looking at each of these like individual boxes as the price that he's looking to sell at, yeah. So he sells 1 here, he'll sell 2 here because he'll sell to both these people if he charges $14. So he'll make 28 there. If he charges $12, all 3 of these people will buy, and he'll get 36. If he sells here, 4 people will buy, and he'll get $10 for each of them, so he'll get $40. Here, 5 people will buy. It doesn't go up at all in his total revenue there. 6 people will buy here, 36, so his total revenue is going down now. At 4, he gets 4 times, how many did he get? 7. 28, and 8 times 2 would be 16. So just again, summarize. If he sells each basket for $2, he'll sell to everyone. So he'll sell 8 baskets, but he'll only get $2 a basket, so his total revenue will be $16. I might just have to Okay, so now we need to draw the figure out marginal revenue so that we can draw, let me see, I think it's required for part of the problem.
Yeah.
Okay. So marginal revenue is going to help us figure out at what point, as a monopolist, he would sell. He's the only person selling baskets. Okay, so for the first basket, Solomon gets $16 of additional revenue by selling that one basket. By selling one additional basket at $14, Solomon goes from getting $16 in revenue to getting $28 in revenue. So his marginal revenue is 12, because it's 28 minus the 16 that he would have gotten already. His marginal revenue for selling 3 baskets at $12, he would go from making $28 in revenue to $36 in revenue. So he would get $8 of additional marginal revenue. Going from here to here, he gets 4. From here to here, he gets 0. From here to here, he gets -4. From here to here, he gets -8. From here to here, he gets -12. Okay, so part F says, now let's say that Solomon is driven by profits, but can still only charge one price. What price will he sell for, and how many baskets will he sell? So remember, his marginal cost is $3. Did it say that in that last part? Did I skip it? Oh, okay. So we'll have a point at 16, 16. Oh gosh, I didn't go to the graph again.
1 of 16 to 12.
Okay, so 16. So there's a point here for the, so now I'm graphing this marginal revenue because I didn't do that before. Sorry, moving back to E for a second. So I'm just going to look at the willingness to pay and, oh wait, no, that's not right. Let me look at the slides real quick, just to make sure. Yeah, so I should have thrown that. Okay, so since this is a demand curve, we already know that the marginal revenue curve is going to be about half of it. Look, something like this, halfway horizontally. Yeah, we know when he sells 1, he gets $16 in profit. When he sells 2, he's gonna go down to about 12. And so forth. It just goes down faster because instead of, so in this line, we have willingness to pay numbers or demand. And then this one is marginal revenue. Okay. Does that make sense with the graphing? Or should I go? Okay, makes sense. Let me see actually. We have one viewer right now, but oftentimes people watch it afterwards. Okay, so okay, now I'm going to move to F. So now let's say Solomon is driven by profits but can still only charge one price. What price will he sell for, and how many baskets will he sell? Remember, his marginal cost is $3. So he's going to sell, the profit maximizing place is when marginal cost equals marginal revenue. So we have our marginal revenue. Trying to think how to explain that marginal cost is equals marginal revenue is the most profit maximizing place. Okay, so every time that Solomon lowers his price by $2, he loses $4 of marginal revenue, right? He loses the $2 from the additional $2 from this person, and he doesn't. Let's see here. So yeah, moving from here to here, he sells 2 baskets, but he doesn't make $16 a basket anymore, so he loses 4 because he loses 2 here, and he loses 2 here essentially because he's not making 16. So going from here to here, if he loses, he goes from 16 to 12, so he's minus 4, and it keeps going on that way. Every time he lowers his price, his marginal revenue goes down by more than the price lowered. Until the point right here when he doesn't earn any additional money by selling more baskets or lowering his price more. Because actually here he puts, like after point when he after this point here at $10 per basket, he's only going to make $4 on that basket. So if he sells any more, he'll go to $0 additional for making another basket. So if you see at this point, he goes from selling 4 baskets, 1, 2, 3, 4, at $10 to 5 baskets at $8, but doesn't make any additional money on that last basket. His total revenue is still the same. Yeah. Yeah. So no matter what his marginal cost is, even if his marginal cost was $1, it would never make sense to go all the way down to when your marginal revenue is 0, because you're not making any additional money by doing that extra work. Yeah. Yeah. Oh, well, he just chose the amount for willing to pay. I think the first part of that explanation wasn't as good as the second part, so I would maybe not focus on the $2 specific, which is just to say that when he sells 4 baskets at $10 and 5 baskets at $8, he only makes $40 either way. So why did it make sense to produce another basket? Why would it make sense to lower the price? He didn't make any additional money. Yeah. And so because his marginal cost is $3, it would never make sense to him to sell when his marginal revenue is less than $3, because that's the point at which he wouldn't get any additional money by lowering his price and selling 1 more basket. So here, you wouldn't want to go below this point, right? Because here is below $3. Here is just about $3, so this is still a good point to produce at.
This is sell more or
Well, he doesn't want to lower his price more than $10. Yeah. So this is the profit maximizing point right here. Marginal revenue doesn't exactly equal marginal cost, but if he goes any lower, his marginal revenue will be lower than his marginal cost. So that's how you know when to stop. As soon as the number in the marginal revenue column is below the number in the marginal cost, you don't go there. So for F says he's driven by profits, but he can only charge one price. So what price will he sell for? Well, he maximizes his profit by selling here at $10 a basket. And he will sell 1, 2, 3, 4 baskets there. He'll sell A through D. Okay. So Solomon is going to get, so here's the price, right? He's going to choose to sell for $10 per basket. And he's going to sell 4 baskets. So that's $40 in revenue, like we said, right here. But he's going to make, does it ask about profit specifically? Yeah. Well, it's going to be $3. So we have total revenue, $40 minus the marginal cost for each basket, which is $3. So 3 times 4 is 12. So he's going to get $28 in profit. This is his total revenue minus total cost equals profit for him. How much surplus was lost? We might want to go to the graph for this one and just visualize it first, and then we can figure it out afterwards pretty easy. So here was his marginal cost, and I'm going to erase these now. So Solomon is going to produce to this point here. They're only going to sell 4, and it will be at the price of $10. Okay, so how many are they selling? They're going to sell 4. The price is going to be $10 for Solomon. And so the question is asking how much surplus was lost. Before, we would have been selling all the way up until this point here at G. So we would have sold 7, 1, 2, 3, 4, 5, 6, 7 baskets. And they would have been sold at $4 a piece. So all of the surplus between this demand curve, so all the surplus after the quantity of 4 here would be lost. Because none of these transactions are happening anymore, because Solomon was able to kind of, he was able to choose the profit maximizing condition and sell it at a higher price than these people are willing to pay in such a way that he increased his profit as much as possible. So the surplus that is lost right there is all the people that would have bought if he hadn't chosen the profit maximizing condition. So he would have sold to, he's only selling to A, B, C, and D when he's profit maximizing. But if it was a social maximizing, he would have sold also to person E, F, and G, because G is willing to pay $4, which is more than his marginal cost. So yeah. So it's dead weight loss point. And the way that we would calculate it is by determining what so we would have sold at $4 a piece before. So we're just going to subtract $4 from each of these people. Actually, is it $4 that he assumes, or is it $3 that he assumes? Oh, okay. So he assumes that the price would have been $3 before, that he would have just let all the consumers capture all the profit. In reality, it could have been anywhere between $3 and $4, and it still would have, the transaction still would have happened. So Solomon isn't willing to sell below $3. So for this part, we're just going to assume he would sell at $3. And so for each of these people, you want to subtract the price that they're paying from their willingness to pay. So I'll just do it down here in purple. So for these, you're going to get 8 minus 3, which is 5. Yeah. So these transactions would have happened in the socially optimal place, but they're not happening. And so all of the consumer surplus that they would have received is gone, and it's dead weight loss now. And their consumer surplus would have been equal to the number that they valued the basket at minus the cost that they paid. So that includes. Yeah. So here it'd be 8 minus 3, so 5. Here it'd be 6 minus 3, so 3. And here it would be 4 minus 3, so 1. Which equals 9 total. So that's how much surplus was lost. If Solomon can somehow price the baskets differently for each person, for example, he sees a tourist walk in and he says, oh, I know that this person would be willing to pay $14. And so maybe he would barter with that person and try and actually capture the entire $14 that he thinks that person values it at. If he's able to do that for every single one of these people, he kind of can tell how much he thinks they'll value the basket at, then he can really increase his profit even more. Because instead of getting only $10 per person, he can get exactly what the person values it at, which would be more for person A, right? He could get the whole $16. I'm going to erase something. So to figure this one out, he would just sell it to each person for exactly what they were willing to pay, and he would get, in profit, he would get that number minus the $3 that it costs to make each basket. So he'd get $13 for person A, because it would be 16 minus the $3 that he had to pay to make the basket. Here it would be 11 Here it'd be 9, 7, 5, 3, 1, and -1. So that's, doing the subtraction, 10 minus the $3 it costs to make it a 7, and then just continue with that logic down. So if this is the case, he could get, these would be all the potential profits that he would get by price discriminating. In this case, he would sell to this person, he would sell to everyone for which he made a profit on them. So he would sell all the way to person G because he made a $1 profit on them. And he wouldn't sell to person H. So his total profit would be the sum of all of these numbers. So 4, 9, 16, 25, 36, 49. So this is how much profit he would make if he was able to price discriminate. He would charge everyone exactly what their willingness to pay was, because that's the most you can charge a person. You still have to do business with them. So is that the end of the problem? I think it is. Okay, so now I'm going to move on to number 2 from that problem set, which I kind of covered in the, I think I kind of covered it, but I can do it again because it was requested. Okay, so Reese's peanut butter cups have a patent on the recipe, so no one can copy them. In other words, it's a monopoly. The marginal cost of making the cups is given by Q equals quantity supplied equals P, and they face demand of quantity demanded equals 30 minus P. So graph the demand, supply, and marginal revenue. So quantity supplied is just going to be intercept at 0, 0, and goes up by 1. Slope of 1. Quantity demanded is going to be 30, starting at 30 for the price intercept, and it's just going to go down by 1, slope of -1. So that means this will intersect at 30 as well. And then the marginal revenue curve, we know from class that Dr. Turley says we just assume that it's horizontally half of the quantity demanded curve. So if it's horizontally half, we know it's going to intersect at 15 instead of intersecting at 30. And it's still going to intersect in the same place up here. So okay, so those are the graphs for that. What quantity will they sell? Okay, so actually I'm going to also put up in here this marginal revenue equation. Well, Okay. Okay, so what quantity are they going to sell and at what price? They're going to sell where marginal revenue equals marginal cost. So we can think of supply as the marginal cost. So where marginal revenue meets this marginal cost right here indicates the quantity that they will sell. So the first thing we want to do is set this equation equal to this equation to find out one of these quantities. Okay, so we have P equals this equation for this line here. So 15 minus 1/2 P. So we have 15 equals, I'm going to add 1/2 P on both sides, and I'm going to get 3/2 P equals 15. If I multiply both sides by 2/3, this cancels, and this times 2/3 equals 10. So P equals 10. So we're actually trying to find this quantity. That's helpful, knowing P, because we can solve with this P, we can now solve the equation for Q to figure out what that quantity is. And then once we have that quantity, we can continue and figure out what price Reese's is going to sell at. Okay, so now we want to know what this quantity is, and so we're going to plug P into one of these equations. It looks really easy to plug P, this P value here, into this equation because Q equals P. So we know that at this point, if price equals 10, quantity is also 10 because Q equals P on that supply curve there. Okay, let me see how the question is worded again. So now that is part B. The quantity they'll sell is 10. What price will they sell at? It might be tempting to say, oh, they sell at $10, but that's not true. Reese's is going to try and sell, so if they're a monopoly, this is the quantity they're going to produce right here. But they're going to sell it at the highest possible price. So they're going to follow, even though they're selling only 10, and it only costs them $10 to make each of those, they're going to go all the way up to the demand curve where they can. And they're actually going to sell at this price point. They want to capture the additional surplus for themselves. Yeah, I'll figure that out. So here, what we want to do is say, okay, well, how do we figure out what the price is right there? We would figure that out by taking what we know, which is that the quantity has to equal 10. And we plug that into whichever equation we're supposed to plug that we can to figure out what this other point is for P. So we're going to want to look at the demand curve to figure out and plug in our quantity value to figure out the P value. So we have Q equals 30 minus P. We know that Q equals 10, so we can do 10 equals 30 minus P. Subtract 30 on both sides, and you get negative 20 over here equals negative P, so P equals 20. So when marginal cost equals marginal revenue, that's how we figure out the quantity. And then to figure out the price, we go back to the demand curve and we plug in that quantity that we found to figure out the price that they will charge as a monopoly. Producer surplus is going to be, let me see this. Yeah. So the producer surplus is going to be everything below the demand, everything below the price point, which is here, and above the supply curve, which is here. So producers are going to get this entire area, right? They were willing to supply this many at this cost, but they charge all the way to 20. They're willing to supply this many at this cost, but they still charge all the way to 20, and so forth. So that's the producer surplus there. And consumer surplus is still the space below the demand curve and above the price curve. So this is consumer surplus. And producer surplus is there. Okay. So to figure this out, we're just going to do the area of this square here, or this rectangle, whichever. It's going to be a square, but so this here, and then plus the area of the triangle here. So the area of this square is going to be 10. This is a length of 10 between 10 and 20. And here we have 0 to 10, so that's also 10. So we have 10 times 10 plus 1/2 of this triangle. So the length of that triangle is 10 from here to here. And the height of it is also 10. So we have 100 plus 50, or a producer surplus total of 150. Consumer surplus is going to be the area of this triangle, which is 1/2 times 10 times 10. So 1/2 times 10 is 5, times 10 is 50. So consumer surplus will be 50. That makes sense? Okay. What will be the deadweight loss from having a monopoly instead of a competitive industry? Well, if there wasn't a monopoly, we would have just sold, rather than, we sold where marginal cost equals marginal revenue, but if it wasn't a monopoly, we would have sold at supply equals demand, which would have been right here. So what transactions would be happening in the socially optimal solution that aren't happening now? All of these, right? So that's the deadweight loss right there. Oh, did it want us to? We can do that. So the quantity of this deadweight loss would be the length of the triangle. So it's going to be the area of a triangle that we're going to use. We have 1/2 times the length of the triangle, which is 10, times the height of the triangle, which is this point, this area between 10 and 15, so it's 5. Which is 1/2 times 10 is 5, times 5 is 25. So that's the end of that problem. Okay, I got a request for review number 3 now from that same problem set, so I'm going to go to that. Guys, just to give you a warning, I forgot my charger at home when I came here, so I don't have, I can only stay as long as my computer is alive, so when my computer dies, office hours are ending. It has like almost like a USB sized charger. Yeah, it's like kind of weird. Yeah, I don't have the round one. I think so. Okay, so now I'm going to move on to review question 3. Which says, okay, so think of a scenario in Provo where a business experienced either positive economic profit or negative economic profit, and the market changed as a result. Describe the scenario below and graph what happened according to the principle of the invisible hand and equilibrium. So on the left, we're going to graph the market, and on the right, we're going to graph the individual firm that we're looking at. So it's like the corn example from last week. See an example below, we're representing positive and one showing what happens with negative profit. So, okay, over here I'm going to draw our market graph, which is going to be supply and demand. And over here I'm going to draw the individual company graph. Okay, so let's say we have a scenario where we have a supply of this, supply 1, and a certain demand. So this is going to be the equilibrium point, and we're going to get an equilibrium price from that point, from the market. That means that this person is they're pretty much a price taker. They just have to charge whatever the market says they can charge. They can't charge more than that, and they wouldn't want to charge less. So they're going to charge at this price point over here. Well, so we haven't gotten the invisible hand yet. Right here, I'm just drawing your regular supply and demand, and that's the equilibrium. So this is the equilibrium price. So for the whole market. Oh yeah. So this is for the whole market, and so when the whole market decides what the price is, then any individual firm is just a price taker, because unless they're a monopoly, they can't charge whatever. They can only charge this point. They can't charge more, like I said, because no one will buy. They'll just go to somewhere else. Yeah, and they can't charge less. So then over here, we're going to have our marginal average total cost and average variable cost curve. So I'm just going to draw like a hypothetical one. Marginal cost. Average total cost and average variable cost. Okay, so if this is what the market is saying the price is, we'll say, okay, so for example, the key has this as an example. The frozen yogurt industry, there's probably a lot of positive economic profit in the beginning, which would be shown in this, well, I guess it would be shown. So there is still a market for yogurt in the beginning, and we'll say that this was the original price. Let's say, I don't know, $1 an ounce maybe, which would be a lot, but so let's just say the equilibrium price is $1 an ounce for frozen yogurt. That means that any individual producer is going to charge, they're going to have to charge $1. They can't charge more. They wouldn't want to charge less because they'd be losing money. And so they will charge $1, and their economic profit is going to be equal to the amount above their whatever amount their marginal cost is above their average total cost. So they're making a lot of profit here, right? You draw it different. It kind of depends on how you draw it. So this is over here, it's going to be the same price point as over there, which is $1. So we kind of assume that these two axes are the same. Labeled the same by the same increments and stuff. Because that's how we make this graph useful. Is by making the scales the same so that we can see what, the $1 corresponds to $1 over here, which gives us this much economic profit. And then if this, since there's so much economic profit to be had in this industry, other people might want to join the frozen yogurt industry. So we get more suppliers, and they're willing to supply yogurt at even cheaper amounts than, because of that, they're willing to charge less. And so maybe when they enter the market, they drive the price down to 75 cents an ounce. Then this person is going to be, this is going to be the market price. They're not going to be able to sell for more than that, so they're going to sell it at that price, so 75 cents. And people are going to keep entering the market and driving down those prices until there's no more economic profit that you can make. Yeah, so I mean, right now we can see how much the economic profit has already dropped from me moving the supply a little bit, right? It's dropped from this big purple box here to this this little orange area here, and they'll keep going. Suppliers will keep entering the market until there's not an economic profit anymore to be had, until you don't earn any more money in the frozen yogurt industry than you would somewhere else with the opportunity cost. Mm-hmm. Yeah, because John makes a good point. So when people enter in the market, it might be the case that too many enter the market because they're not able to see the adjustments in the market fast enough. Right. So like so many frozen yogurt companies saw this profit to be had, and they jumped in that they effectively pushed the supply line too far until it's at 50 cents per an ounce, and they suddenly don't have any economic profits anymore, right? And so if that was the case, which we could also use as an example in this case, we could say, well, the frozen yogurt market now is kind of different. If they're making negative profits, so more frozen yogurt places are closing because they don't want to be in this industry anymore. So here would be the negative economic profit. Between marginal and the average total cost. So this would all be negative economic profits if you're looking at a yogurt industry where there are too many yogurt producers, and they're going to drop out of the market, and the supply is going to shift back until they get to a point again where there's just zero economic profits to be had. People will just keep dropping out until they get to that point. And then the next dessert phase will start, which will be cupcakes or something, and then everyone jump into that market, and then everyone jump out of that market, and I'll just keep going vicious and very sweet cycle with the dessert. So that's number 3 on there, on the review. Do you have any other questions on that at all? Let me see what the next request is. Okay, so it looks like we're going to move on to problem set 9 now a little bit. That's where we have more requests. And we're going to start with, let's see here. I don't know when it's due, I'm sorry.
Oh, this is kind of good with lots of times. I don't
No, he's like changing all the time. I don't really. Okay, so we're going to start with number 7 on this problem set because it was requested a few times. So we're doing the ultimatum game, and we're supposed to imagine that we're in pairs with one person assigned the role of player A and the other person is player B. So if you're player A, you're given $10, and you are then asked to decide how much of that $10 you want to share with another person. And you might choose $1 or $5. The other person is then told how much has been shared, and they have to decide to accept or reject your offer. So if they accept, then they get the proposed division, and if they reject, you and that person get 0. So we have player A, which I was saying was you. And you have 2 options. You can either give $1 or $5 to the other person. And then it comes to player B's decision. And that person gets 2 options as well. So no matter what you offer them, whether it's $1 or $5, yeah, so whether you give them $1 or $5, they still get 2 options. They can either accept or reject. So still get 2 options. So I'm just going to say accept is A and reject is R. So if I'm going to put the payouts here. So if player A offers $5 and player B accepts, then player A gets $5 and player B gets $5 as well. If player A offers $5 and B rejects, you just get $0 and so do they. Which is also the case if they reject down here. Nobody gets anything. If player A offers $1 here and player B accepts, then they will get, then player A is going to get $9 because they had 10 and shared 1. And player B gets $1. So those are the possible outcomes. In extensive form. So I have this written like A, comma, B. Yeah, all of these. So this, all of the first numbers are the payouts for A, and all of the second numbers are payouts for B. So now we're gonna, so that's extensive form for part A. Now we're going to model the same game in normal form, which is the table. So we have player A, who can either offer $1 or $5. Too small. Okay, so player B is over here. And they had some options as well. They could either, John, I actually have a question for you. Do you remember in class what he said about why he had, how he explained this AA? Okay. Oh, okay. So in this case, if player A, or if player A offers $5 and player B accepts, so we're looking at this first option here and this first option here to get this value, then player A gets 5 and player B gets 5 as well. If player A offers $1 and we look at this second option over here, which is also accept, then player A gets 9 and player B gets 1. So this is to this box, this is to this box. It looks like in his example, he actually did play, like he did the outcomes and B, comma A. So in Dr. Turley's example on his slide, these two numbers are switched because he put player B's payoff first. So I guess I'll just do it the way that he has it in the slide. So for all of these, we're going to look at player B's out payoff and then player A's payoff. Okay, so if player A offers $5 and player B accepts, we have 5, 5 here too, because we're looking at this first option. And then if he rejects, then everyone gets 0. So the first, is that making sense that we're looking at the first letter for the first box, the second letter for the second box? Okay. So here we're going to have the first, B is going to reject in the first box, which we know corresponds to 0, 0. And in the second box, he accepts, which we know corresponds to the payoff of 1 for B and 9 for A. And down here, he's going to reject in both scenarios. So these are all, if you're player A, you're saying to yourself, there are several different ways that player B can respond. And you have to try and think, what kind of player B do I think I am I'm playing this game with? So that's part B of that problem. Okay, so first, in order to, what was the question? All the Nash equilibria. Good, you guys can still see it. Okay. So a Nash equilibrium is where no player has anything to gain by changing their strategy. So for each of these strategies, we're going to look at what player, so player A is going to move first. They get to decide how to divide up the money first, and then player B gets to decide whether or not to accept, right? So let's look at player A's first. Player A is again the second payoff. So between this payoff and this payoff, player A is going to prefer this, right? Between this payoff and this payoff, player A is going to prefer 5 over zeros. Between this payoff and this payoff, player A is going to prefer 9 over 0. And I've only got 10% battery left, guys. It might end pretty soon. And we also know that this is a completely dominated strategy. Player B is never going to choose to reject and to reject, because in that case, he has always something to gain by moving to a different decision. If he were, say he's over here and he's saying, I don't want to, he's offered $1. He might say, oh, I don't want $1, that's not a good deal, but it's still a better deal than getting 0. And so it would be better for him to accept here or to be in one of these boxes instead, because if he's comparing this outcome, player B outcome, to other possible player B outcomes, logically he should move to one of those other areas. Change his strategy.
This is based on the $5, $1.
Mm-hmm. Yeah, we could have chosen any dollar amounts, and the payoffs would have changed a little bit because you're dividing $10 with people. So if this person gave $3, then we have 3 and 7. That makes sense?
Yeah.
Yeah. Well, if you're dividing $10 between 2 people, the maximum number is 10. So the most you can share is 10, the least you can share is 0. And if you shared 3, then you would stand to gain $7, right? Because you get the remaining, and the other person would get $3. So that's why it would be this other person would get $3 and you would get $7. In this case, you're sharing $1, so you give player B $1 and you go on with 9 if they accept your offer.
So $10, why would you talk?
Oh, so he just chose these 2 values. That's how the game is defined in your problem. So based on the information, this is information he just gave us. We don't know where it came from. Okay. Yeah, so he just said you use $5 and $1 as examples. But reasonably, you could do any number between 1 and 0 and $10. So if person A shares $5, B wants to be, he doesn't want to get $0. So we're looking at the first number now.